Lesson 53, we're going to look at what's called 45, 45, 90 triangles. These are considered special right triangles because their parts will always be the same. They will follow basically a formula, is what you could call it. And so a 45, 45, 90 right triangle, first of all, you have two angles that are 45 degrees, and your third angle is 90. Well, we already know that our legs are congruent because it's an isosceles triangle. They have the same angle measure, so these legs are congruent. So these we're going to label with the value of x. The hypotenuse is the only one that's kind of different. With the hypotenuse, you can use the formula of x times radical 2. So in any 45, 45, 90 triangle, you can go by this formula. So let's look at example 1a. And it wants us to find the missing parts of x and y. So let's see. We already have 2. Well, the easy one to do here would be y, because we know these are both 45 degrees. It's isosceles. So therefore, this is also 2. All right? That one's also 2. Now, looking back here, how did we get from a leg to a hypotenuse? What did we do? Well, we would take our number. X refers to our number that we have for our leg. X is the value of the leg. So our value of the leg here is 2, and then we multiply it by radical 2. So the hypotenuse would be 2 radical 2 inches. And that's how you do 45, 45, 90. Now let's look at a different one. Example 1b gives us a hypotenuse of 3, and then it gives us our sides. Well, the first thing we can know is that both of our sides are the same because it's a 45, 45, 90. It only gave us one 45 degree angle measure, but since this is 90, triangle sum theorem, that's 45. So we can assume that both of these sides are the same. So we only need to solve for one leg. So if we look back at this triangle, a leg is the value of x, and to get to a hypotenuse, we multiplied by radical 2. This is x times radical 2. Well, how do we get from a hypotenuse to a leg? Because that's what we have here. We have a hypotenuse, and we have to get to the leg. Well, if we multiplied by radical 2 to get leg to hypotenuse, then if we're going backwards, we would divide by radical 2. So this would be 3, looking at x, 3 divided by radical 2. Now, technically, this is not simplified. You do this more in Algebra 2. But in order for an answer to be simplified, you cannot have a radical in the denominator. Radical 2 right now is in the denominator. So to get rid of that, all we actually do is multiply by radical 2 over radical 2. That's the same as multiplying by 1, because this divided by itself is 1. But notice what happens when we multiply by radical 2 over radical 2. In the numerator, we do 3 times radical 2. And get 3 radical 2. And in the denominator, we do square root of 2 times square root of 2. Well, what that equals is square root of 4. And square root of 4 is a perfect square 2. And so kind of the rule for radicals is if you multiply 2 of the same radicals, it comes out to just be that number one time of the whole number. So this becomes 2. So this could be that would be the measure of our leg. That's a measure of our leg. Let's look at example 2, where it says find the perimeter of this triangle, and it already gives us a side length of 12. Gives us 90 degrees 45, so we can automatically assume that this is 45 degrees. If that's 45, 2 of our legs are the same. That's our other leg. That's easy. Now, how do we get from leg to hypotenuse? We simply multiply it by radical 2. So these are all of our side lengths. So when we add them together for our perimeter, we would do 12 plus 12 plus 12 radical 2 equals perimeter. Here are some like terms. 24 plus 12 radical 2 equals your perimeter. And you could actually leave it like that. If we're doing our measurement, let's see what our measurement was. Yards. You could write it like this and put yards here. You could actually put that in a calculator if you wanted to and get roughly 41 or 40.97. But this is actually appropriate and would work as well. Now, if you didn't want to use that formula, example 3 shows that you can still solve by using Pythagorean theorem. Now, I think the formula is easier and quicker, but I'll show you that Pythagorean theorem still works as well. Find the missing sides. 45, 45, 90 triangle. So both sides are congruent, so I can call this x, and that one has a value of x as well. Same number. So Pythagorean theorem is leg squared plus leg squared equals hypotenuse squared. Now notice what happens when I add these together is I get 2x squared. Doesn't become x to the 4th. You only do that if it's being multiplied. And then 125 squared is 15,625. Now we got to get x by itself. So what I would do here first is divide by 2. So divide 15,625 by 2, and I get 7,812.5 equals x squared, and you should know what to do from here. Square root it. Square root of 7812.5. You get 88.4 roughly. Put that. For a side. And so both of them are the same. So found one, you found the other. But that is how you could use Pythagorean theorem in these 45, 45, 90 triangles if you didn't want to use a formula. But I would definitely recommend knowing that formula because it should be a shortcut and save you some time.